Hello students, welcome to Samclasses. The first topic is pretty simple kids, matrix. Now we all know about matrix, we have studied in PUN about matrix. Now in this video lecture, we can't do much of joking. Mostly when I teach, we are involved in funny ways, we discuss, we laugh, we do a lot of stuff. But here kids, we have to be restricted, we have to be serious, time is of the essence and we have very less time. It's a crash, and plus in 1.5 months we are providing you with everything from top to bottom, from basic to advanced. So we have to be a bit serious, students. Now matrix, as we know, or matrices, the plural form as we know, is nothing but just an arrangement. What kind of arrangement? Arrangement in the form of row and columns. What are these rows and columns? I'll make you understand. Or a rectangular rectangular array of numbers. It can be functions, it can be other stuff also. Now numbers can be a real or a complex also. Now see, we already know that this matrix is denoted by a capital letter. First we denote it by capital letter. Okay, capital letter. Second, the inside elements are denoted by small letter. So these two things are pretty basic. Now this horizontal one is nothing but your row. So a lot of students, they have doubt, sir, what is the row? Okay, we get confused between rows and columns. Okay, this the sleeping line is the rows. So this is the row 1. You can write it as row 1. This is nothing but row 2. You can write it as row 2. This is nothing but row 3. So we have 3 rows in here. Okay, and what I told you, the standing line is the column. So this is nothing but, or the vertical, we can say it is a column. So this is my column 1. Now in case if there is a bit small spelling mistake here and there, do ignore it. I'll try not to make it. Okay, column 2, this is one column 2, and this is our column 3. Okay students, so carefully note it down. Very important point from here is sleeping line. Okay, is your sleeping line is your row, and standing line is your column. Standing line is your column. Okay, so very important. Now a lot of people we see, sometimes they say row you can extend it like this. So sleeping line horizontal, you can write it like this row, and column you can use like this also. So whichever way suits you, you can take that one. Okay, so what we have seen here, students, is we had 3 rows, 1 row, row 2 and row 3. So first in a matrix we write the number of rows. The order we write as number of rows into the number of columns. Number of rows into number of columns. So we have 3 rows, 3 columns. So that's why we have written 3 cross 3. Okay. Till here any difficulty? Do comment it in the comment section or in the WhatsApp group. Okay. Next part. So now we know about the rows and columns. How do we show it? How do we denote it? This either in a box form, we put the array of elements, or like this, a big, what do you say, parenthesis. Now, matrices are denoted by, a matrix we denoted by capital letter and its element by small letters. This I denotes the number of rows and J denotes the column. So if this first element A11, so the first one denotes the first row, that it is of first row, and the next one denotes that it is of first column. So this element is belonging to first row, students, and first column. That's why it is written A11. Understand, very important. Now next one is A12. How we can say A1 means what, students? That it is belonging to the first row, and 2 means it is belonging to the second column. So very simple. Okay, so the last element, let's see the last element, M rows. Total we have M rows, students, so that's why M here, and we had N columns, so that's why N, AM into N. Okay, so very important. So what is the order of a matrix? M cross N, where M stands for the number of rows and N stands for the number of columns. So very simple in this, nothing goes in this. How do we denote it? Capital letter, elements inside by small letters, and then each element, how do we write it? We got to know it. Let's see a question. So the first question is very simple. A matrix is given to us and they're telling that the matrix contains how many elements? 8 elements. Now they're telling that what are the possible orders? Very simple, students. So it can be either what? The number of elements is always equal to the total number of elements is always equal to what? The rows into columns. You multiply the number of rows with the number of columns. multiply the number of rows with the number of columns, you'll get the total number of elements. So you can have one row and you can stack all the 8 elements in one column. You can have 8 columns, sorry. One row, 8 column. You can take 8 rows and with each row one element. You can take 2 rows and 4 elements in each column, or 4 rows and 2 elements. So total we have 4 ways of doing this. Okay. So the possible order is how much? 4. Either 4 into 2 or 8 into 1 or 2 into 4 or 1 into 8, students. So very simple question. What is the total number of elements if it is given to us? That is equal to the number of rows into number of columns. So just we'll do all the factors and we will get it. Okay. Now coming to the next section. Now, in the next part, we'll see how do we construct a matrix. Now, sometimes they'll give you a formula kit. Okay, so what they will do, they'll give you a formula. Now, that formula will be based on, it can be anything. Okay, so here they have given you modulus. We already know what is a modulus. What is the modulus, students? If you don't know, modulus, what it does, if I have modulus x, it always brings the positive value outside. What it does, it always brings the positive value outside. So mod x, if you see, it can be represented as x when x is greater than or equal to 0, students, and minus x if it is negative, you put a negative sign when x is less than 0. Okay, so here they have given a very simple question, students. A of ij is nothing but mod of I minus j, okay, divided by 2. So now first element is what? 1 1. We have to make a matrix of 2 rows and 2 columns. So how it is like that? This is like this. So how many elements will we have? A11, A12, A21, A22. Okay. So now the first element A11, how will we find it out? Put in place of I1 and in place of J1. So 1 minus 1 is how much? 0. 0 by 2 is always also 0. So the first element we got 0. A21. So 2 minus 1 by 2. So that is equal to what? 1 by 2. Correct? Now A12. So 1, I is 1, J is 2. So 1 minus 2 by 2. So that is equal to half. Now it was minus half since modulus is there. What is the function of the modulus? If a number is negative, just bring out the positive. A22, it is equal to 2 minus 2 by 2. So 0, 0 always. Now 0 again, it will come out like as it is. So what we got the matrix, students? 0, half, again half, again 0. Okay. So this is the matrix A. We can write it as A is equal to this. Clear? Pretty simple. These are all you have learned in PU. Just going a bit in depth and slowly, we'll start making the courses a bit faster. Okay. So wherever you are having a bit doubt or you want to make it a bit slower or anything else, do put your comments on the comment section because we read it dedicatedly and we try to reply most of them. Okay. Next. Now the second thing what we'll be talking about is the types of matrices. Now here among that the first thing is the row matrix. Row matrix is nothing but just one row. Okay, a matrix which is having one row. Now it's just the number of columns, as many as you put it. Okay, it can be one, it can be two, it can be many, it can be infinite. Okay, so whatever it is, if the rows number is one, that is a row matrix. The same way we can define column matrix, students. What is column matrix? If the number of columns is one. Now, what about the number of rows? So there is no condition on the number of rows. You can take it as many as you want. Okay, the number of columns should be one. Apart from the no else condition. Okay, so I can make it like 1, 2, 3, 4. How many rows I have, students here? 4. So I can take it if I want. Somebody says, sir, I want to take a 1, 2, 3, 4, 5, 6, 7. So I can write it as 7 rows here and 1 column. So this is a column matrix. Now coming to the next type, 0 slash null slash void. Now a lot of people they say 0 matrix. A lot of people they will say null matrix. A lot of people they will say void matrix. So don't get confused. All three things belong to the same thing. They all point to the matrix where all the elements are 0. Now a lot of students they have a confusion. Sir, what if few more elements are 0 but not all of them? Then it is not a 0 matrix. All the elements A of ij is equal to 0. Any order, students, doesn't matter. 3 cross 4, 4 cross 3, whatever order, doesn't matter. If all the elements are 0, directly we can say it is a 0 slash null slash void matrix. Coming to the square matrix. Now, the moment we say square, we picture around having length and breadth as the same thing or both equal to a side. So here also it's same thing, students. The number of rows it will be equal to the number of columns. What is a square matrix? Pretty simple. Always keep your definition too simple so that it becomes very easy for you to remember it, to understand it for longer time, and to keep it or retain it. So number of rows equal to number of columns. That's it. So the order will remain same. So somebody will say, sir, n corresponds to, what is it, the number of columns, n corresponds to the number of rows also. Simple. So here it is 3 rows. We can see the first row, second row, the third row, the first column, second column, and the third column. The order is how much, students? 3. Okay, 3 rows, 3 columns. So the order is 3. Very simple. Now, in here, one very important concept. Sometimes, a lot of times, it has been asked in KCT also. What is the trace of a matrix, students? What is the trace of a matrix? Now, this word trace, the moment you hear this word, ring a bell in your mind that it is nothing but the sum of the diagonal elements. Nothing but the sum of the diagonal elements in a square matrix. So what is a trace of a matrix B or trace of any matrix, students? Sum of the diagonal elements in a square matrix. So what do you need to keep in mind? This one. The sum of the diagonal elements in a square matrix. Again, say it if you want while writing the notes. Do write these shortcuts, okay? And do say it while writing. So you'll understand more better. And wherever you're having doubts, you can join our WhatsApp group or you can put in the comment section. Along with the time, we'll try to work hard and we'll try to make something on that so that you're able to understand in a more better way. Now, if I'm teaching a bit fast, so do tell me, we'll try, or you can go a bit slower in the video. You can pause it and go through once again. And because we have very little time, students, and we have to cover a lot, we can't miss anything so that you students have the ability to attempt everything and you can score 50 plus in KCT. So we'll work hard. We'll try to give you the best we have promised. Okay, let's see. So again, let's recap it. What is the trace of a matrix, student? Nothing but sum of diagonal elements in a square matrix. What is it again? Sum of diagonal elements. What are these diagonal elements? These are the leading diagonal elements. Okay, where I is equal to the number of rows equal to number of columns. See B11. Row and column are both same. B22. Row and column both same. B33. Row and column both same. So these are the diagonal elements, students. Okay. And if we add them, sum means what? If we add them, we'll get the term called the trace of a matrix. Okay. So nobody will be scared by listening to the word trace. Now you know it. Okay. Any doubt? Put it on the chat section or put it in the comment section. Now next is diagonal matrix. Students, what is a diagonal matrix? Very simple. These are all categories of square matrix. Now a square matrix, okay, is a diagonal matrix if all its non-diagonal elements are 0. So what we have done, students, we have kept all the diagonal elements and the rest we have made them 0. So when such condition comes where all the rest elements are 0, leaving the main diagonal elements, then we say it is a diagonal matrix. Okay, it can be order 1, it can be order 2, it can be order 3. Again, understand in simple words. What is a diagonal matrix? A square matrix is called a diagonal matrix if apart from the diagonal elements, all the elements 0. So what you will remember in mind? Apart diagonal elements will be there. Apart from that, rest all 0. Diagonal elements will be there. Rest all elements will be 0. Pretty simple. Nothing much in that. Okay. Don't get confused. Whenever it is B of ij will be elements will be there. Rest all if it is not equal to. Now a lot of people, we can write it in simple way like this also. It is a diagonal element matrix if B of ij is equal to 0, means the element is equal to 0 when I is not equal to j. So it means what it's telling is for the I and j equal will have elements, but the rest others, they all will be 0. So you can understand in more simple words, the diagonal elements like 1, 1, 2, 2, the where I is equal to j, there these elements will be there, except them all will be 0 strings. Except them all will be 0 strings. Okay. Now, coming to scalar matrix. Again, it has to be first a diagonal matrix, and diagonal matrix means it has to be a square matrix. So that square matrix, from there diagonal matrix, and then if all the diagonal elements of a square matrix is equal to some scalar value, let's say k, so then it is a scalar matrix. So nothing condition, a diagonal matrix. So you made these elements are there, you just make them same. Like let's say 3, 3 and 3. So all of them is what? Same. Either -2, whatever element you take, the diagonal elements has to be same. Rest all elements will vanish. There will be 0. That is a scalar. Now you'll say, sir, what if the equal diagonal elements, means the diagonal elements which were equal earlier in the scalar form, I make it to 1. So it becomes an identity matrix, students. Nothing more than that. So if you have a square matrix, first condition is square, then diagonal means only the diagonal elements are there. Non-diagonal elements, we have made them 0. And then it is scalar means what? All of them are equal to one value. And if that value is equal to 1. See, very simple. 4 things are there. What are these 4 things? First, it has to be a square. What does you mean by square matrix? Again, row is equal to column. It has to be diagonal, means all the diagonal elements will be there, rest all will be 0. Rest all will be 0, students. Okay. Then it has to be scalar. Those diagonal elements has to be equal to some value. Okay. Same value. Okay. So once you have done that and that same value will be equal to 1, then we get a what? Identity or unit matrix. So you can see here it is a square matrix, students. 3 into 3. Now, is it a diagonal? Yes, only diagonal elements are there. Very good. Now, is it a scalar matrix? Yes, sir. It's a scalar matrix. Why? Because all 3 of them, diagonal elements which are there, are equal to one value. Is it a unit matrix? Yes, sir. Because this equal value is equal to 1. Okay. Very good. So, very important thing you need to understand here. Every identity matrix is a scalar matrix. Correct? But every scalar need not to be an identity. Okay? Like we can have a scalar matrix like 2, 0, 0, 0, 2, 0 and 0, 0, 2. Now this is a scalar matrix. Very good. Because it's a diagonal matrix. Okay? And it's what do you say, the values are same, but it is not a identity matrix, as the same values, equal values, they're not equal to 1, student. So very important, try to understand, very important. Identity matrix is nothing but square matrix, which is a diagonal matrix, which is a scalar. All values, diagonal elements are equal to what do you say, one particular value, and that one particular value is equal to 1. Now singleton matrix, only single element, nothing more than that. Okay, row and column will be equal to 1 and it has only one element. Okay. Next, coming to triangular matrix. A square matrix is said to be triangle if the elements above diagonal either 0 or below is 0. Simple. So what is it? Triangular. If above it is, see here we can see that below ones are all 0. So it is the upper triangular. Now here we can see that above one is all 0. So it is what? A lower triangular, because the elements are in the lower triangle. Correct. Here the elements are in the upper triangle. So that's why it's known as upper triangular. Clear? Very simple. Coming to the next, a recap section. We first read what is a square matrix, where row is equal to column. And we have 2 types, one triangular and one diagonal. In the diagonal, only diagonal elements were there, D1, D2, D3, let's say, and the rest were all 0. And that is divided into 2 parts, students. Scalar one, where the values were what? Equal to some value, like let's say k, that k can be anything. And then we have the second part, the unit matrix, okay, where in that case of unit matrix, the equal values are equal to 1, students. So this part was done. Here we have upper triangular, where above the diagonal elements were there, a triangle was formed. Here below the diagonal elements are there and triangle is formed, that is lower triangular. So this is the recap of the whole section. Clear, students? Let's move on to the next section. Students, let's now understand the next part. Very simple. Equality. Two matrix A and B, they're said to be equal if they follow 2 conditions. They're said to be equal if they follow 2 conditions. What are these conditions? First, order same. First, order same. Very simple. They are of same order. Whatever the order, then only we can do anything. So first, their order has to be same. And the second part is, what is that, students? That each and every element of the matrix 1 should be equal to matrix 2. So, two matrix 1 and 2 are equal if they have same order, students. Very simple. And second thing, if each elements are equal. Okay. And their order is also equal. Means the first element of here should be equal to the first element of the other one. So don't get confused. Just equal means what? Each and every corresponding elements are equal. Means this first element will be equal to this. This second will be equal to this. This third will be, let's say, equal to this. And this fourth will be equal to this. Okay, students. Let's come to the next part. So if you see this example, students, first matrix is 1, 2, 3, 4, and the second one is 1, 2, 3, 2. See, the last element was not equal. So though they are of same order, they first satisfy the first condition. It was correct, the first condition, but the second condition was wrong. So not all the elements were equal. We need each and every element where it has to be equal. Let's see a simple question. Now here I have taken very less of question. This is more of a conceptual plus formulas based lecture. The second part will be uploading by today or by tomorrow max. It will contain the solved examples from NCERT, from Exemplar, and from the best books available in the market. Now, let's see these two matrices are equal. So they're telling that find the value of A, B, C, and D if both are equal. So very simple. The moment the both are equal, we'll first check the order. Order same, 2 into 2. Here also order same, 2 into 2. Done. Second part, each of this element will be equal to the first element of first matrix will be equal to the first element of the second matrix. So A plus B is equal to 2. Very simple equation. Now, and A minus B, we can make it as 6. So A minus B is equal to 6. Now we all have studied in the smaller classes what the how to solve these kinds of simple equations. So we just add them. So we get 2A is equal to 8, and then from there A is equal to 4. Similarly, we can do C plus D is equal to 4, and we can do C minus D is equal to 8. So the moment we do, just add it up, DD will be cancelled. 2C is equal to 12 and C is equal to 6. So nothing is there in this. Okay, very simple. Let's move on to the next section. Operation of matrices. So basically we'll be discussing about the major 4 operations. What are those? First, addition. How do we add two matrices? Scalar multiplication means multiplying by a value scalar quantity like K, which is not equal to 0. Now, matrix multiplication, when you have two matrices and you're multiplying it, then in that case, how we do it? Difference of two matrices. We have a matrix A, a matrix B. Then if we subtract, what do you mean by that? So let's see from the addition part. Let's say we have two matrices A and B, and we wanted to add it. So first is A of ij, first one, and the second one is B of ij. So the addition is very simple. First we have to check that they can only be added if they are of same order. Again, they can only be added if they are of same order. And the moment we know they are of same order, what we do? We just add them A, B, C, and D. This one plus is not there. E, F, G, and H. So corresponding A is at the first element is added of the first matrix to the what is this first element of the second one. A plus E, B plus F, C plus G, and D plus H. Okay. So what we are doing? The first element of here is added to the first element here, and we got this. Second element of here is added to the second element here, and we got this. Third element of here is added to the third element of this. We got it. Fourth element added to the fourth, and we got this. Okay, students. So each and every element is multiplied. Now, coming to the next part, the scalar multiplication. Okay. In this scalar multiplication, if you are multiplying a matrix with some scalar quantity K, then that scalar quantity is multiplied to each and every element. Okay. Now, a lot of simple questions came in KCET. Okay. A lot of times. So students don't get confused because indeterminate, that is a different thing. In matrices, it is a different thing. So whenever we say 3 times of a matrix A, we mean that each and every element of matrix A is multiplied by the scalar quantity. Here in this case, we talked about is 3. Okay. Now, when we talk about the different students, again, we have to check that the order has to be same. We can't add or subtract until unless the order is same, students. Once we know that, we can just, subtract both the matrices. Okay. Any difficulty, do write us on the comment section with the time specified of the video so we can put our hard work and we can remove that issue. Now coming to the next part, students, the properties of matrix addition. Very simple properties, but sometimes they give us in different forms, so we get confused. So we should know it. Commutative, we all know, if we add first to second or second to first, it's the same thing, students. Now associative means if we add A and B first and then we bring C, then what will happen? It will be same as adding B and C first and bringing A. So that is known as associative. What is additive inverse, students? A, and then if we add with some other matrix such that it gives me a 0 matrix. So that is known as additive inverse. So for in case of A, the additive inverse is what? Minus A. Very simple. Now additive identity, if for a matrix, if I'm adding something so that the matrix again itself appears, so that is known as additive identity. And here in this case is 0 matrix. So A plus a 0 matrix is equal to that same matrix. Okay. Now, next is scalar multiplication. Just now I told we have a matrix, we multiplied with K. Each and every element will be multiplied with K. So very important, students, try to make it a point. Okay. And you don't get confused in the exam. You have to be fast also and you have to do it properly. So no confusion here. Each and every element are is multiplied, not just one row or just one column. Okay, all elements. Now properties, you can multiply it like same different. K will multiply to the first matrix and the second. If I have two values, I can do like this: first time with first value plus the second time with second value. Or if I have two values K and L and then I'm multiplying with A, it's same thing as you multiply the whole thing with K first and then with L. So no problem in that, students. Okay, now. So we can take a simple example of this, like let's say 2 into 3 into A. The same thing as you take 2 into and then make 3 times of that matrix A and then you will get 6A. Okay, students? Now, coming to the matrix multiplication, a very important thing, but very simple. Try to understand. It's very simple, students. Now we have a matrix A of order M cross N. And we have another matrix of B order P cross Q. So first thing and foremost thing we need to know, when is it possible? Can we multiply any two matrices like as it is? No. We have to check if they follow certain conditions, then only we can multiply. And what is that condition? So most of you will be knowing this condition, but still I'll say the number of columns of the first or the A will be equal to the number of rows of B. The number of columns of A is equal to the number of rows of B. Okay, students. So very simple. The number of columns of A is equal to of the first one is equal to this part is equal to the number of rows of this one. Okay, so you can make it, and the matrix which is formed will contain the rest two left ones. So M into Q. Okay, students. Again, let's recap it, students. Matrix multiplication. We have two matrices A and B, and A is of the order M into N, and B is of the order P into Q. So you can't multiply them directly until unless you do a checking. And what is that check? What is that rule? Understand it. The number of columns of the first one or the number of columns of A here in this case is equal to, has to be equal to the number of rows of B. If that is happening, then only we can multiply. Otherwise, we can't multiply. So very important, students. The columns of the first one should be equal to the row of the second. The second thing apart from that, students, what is the new matrix form that will have the row of the first one and the column of the second one? Okay, so very simple. So you can make it like this: M into N, P cross Q. So this and this has to be equal, and the formed one will be M into cross Q. Okay, you can make it like this. Very simple idea. Now let's say an example. A is equal to 1, minus 1, 0, 2, 3, and 4. And B is equal to another matrix 2, 7, minus 1, 1, 5, and 4. So now we want to multiply A and D. So very simple. First we have to understand what is the, what do you say, what is the order here of this matrix, students? 2 rows and 3 columns. What is the order here? 3 rows and 2 columns. So if you can see, these two are same kids. So until unless these two are same, we can't do it. And the next what is left is 2 cross 2. So this matrix has to be of 2 cross 2. So what are the elements? A11, A12, A21, A22. Okay, 2 cross 2. Let's find the elements, students, and let's find the multiplication. Okay, so here we have in this case 1, minus 1, 2, and 0, 3, and 4. And here what we have here is, let's change the color a bit. Okay, now. So 2, 7, minus 1, 1, 5, and 4. So we have already checked that they are compatible for multiplication. So we want to find out what is the first value. So here let's make a big one. So this one A11 means first row and first column. So first row we'll be taking from the first matrix and first column will be taking from the second. And then what we'll do, each element corresponding will be multiplying and adding them. So 1 into 2 plus minus 1 into minus 1 in second of this into second of this plus third of this, the first row element, plus third of the what do you say, first row column. So we got here 2 plus 1 plus 10. So how much, students? 13. Pretty simple. A12 means first row will keep it here, but this 2 stands for the second column, students. 2 stands for what? The second column. So what we do? 1 into 7 plus minus 1 into 1 plus 2 into minus 4. So how much you get? 1 into 7, 7, 1 minus 1 into 1, minus 1 plus 2 into minus 4, minus 8. So how much you are getting? Minus 9 plus 7, students. So minus 2. Very simple, minus 2. Second one was what? 2, 1. So second row from the first one. And the column will be the first column. So very simple. So 0 into 2, again gone, plus 3 into minus 1, plus 4 into 5. So how much you are getting, students? Minus 3 plus 20, that is equal to 17. A22 means second row from here and second column also from here. So 0 into 7, students, plus 3 into 1, plus 4 into minus 4. So that is pretty simple. So 3 minus 16, that is equal to minus 13. So what we have done, students, if our term is, let's say, AMN, so what you have taken, mth row from the first one and nth column from the first one, and then each corresponding elements, we multiply them and then we add with them. Okay, clear? Done. So this is matrix multiplication. Now let's see some question. Now this question is for you students. Okay, pause the video here, try to solve it, and once you have done, do check the answer with the video. So we have a matrix A, that is A1, B1, A2 and B2. And we have a matrix B that is equal to C1, D1, C2 and D2. And now we want to find AB. So first thing what you have to check, students, is whether they are compatible or not. Correct? We always check everywhere we are compatible with someone else or not. So we check with the matrix whether we are compatible to multiply them or not. It is also a 2 into 2. It is also a 2 into 2. So are they compatible, students? Very correct. Yes, you know it. They are compatible. And what is the new matrix form? That is of the left to left ones. Okay. So done. So we already know what are the elements. So first we'll take the first one. A11 will be nothing but first row and first column. So that is equal to A1 into C1 plus B1 into D1. We got it. Okay. A12. That is equal to first row here and second column here, students. A1 C2 plus B1 D2. Very good, students. Now, if you have got the same thing, very good. You have understood the concepts. A21 is second row from here, first column from here. So A2 into C1 plus B2 into D1. A22 is equal to A2 into C2 plus B2 into D2, students. Okay, so this is the answer. You have to put it here. If you got the same answer, students, you got it correct. Let's move on to the next page. Now, properties of multiplication. Now we know they're not commutative, students, because in very few cases it can be like AB is equal to BA, but in rest and maximum cases AB is never equal to BA. Okay, associative law, if I'm multiplying AB first and then multiplying with C, that is same as if I'm multiplying BC first and then with A. So same thing, no difficulty in this in the associative law. Okay, distributive also it follows. If I have A and then in bracket B plus C, so that is same as if I multiply AB plus AC. So no difficulties in this. Now this is very important, students, for your KCET part also. For matrix multiplication, if they say that AB, the multiplication of two matrices is 0, it does not guarantee, students, that either A is equal to 0 or B is equal to 0. Okay, so the moment they say this, they'll give you in the option form that the matrix AB is equal to 0. Can you say that A is equal to 0? You'll say no, we can't say that it has to be 0, or we can't say it has to be the B has to be 0. Okay, students, so be very careful in this. Next is existence of multiplicative identity. Very simple. If you multiply anything with I or a unit matrix of that order, you'll get the same matrix. Okay, A only. So that is known as existence of multiplicative identity. What is cancellation law? This we use a lot, but we don't know how to do it or why do we use it. So if you see good books and from good properties books, you'll be able to understand from addition and advanced ones. I have picked up a few which is needed for the KCET part. Okay, so when AB is equal to AC, students, what we can do, we can cancel the left and left this side, and we can, but yeah, in order to cancel, we have to make sure that A is not equal to 0, students. Okay, and we can write B is equal to C. Now if I have DA is equal to CA, we can do right cancellation. A will be cancelled and B will be equal to C, and here also same case, students, A should not be equal to 0. Now the properties are done. Any doubt, put it in the comment section, students. So let's start with the transpose of a matrix. Now what do you mean by transpose of a matrix? So very simple concept, students. We won't go much in depth, but I'll give you a clear idea. Understand it, very simple. A matrix which is obtained by interchanging the rows and columns. What is it? Matrix which is obtained by interchanging rows and columns. Now a matrix A is given as A is equal to A of ij, and the number of rows is m, and the number of columns is n. Now the moment we transpose it, student, what will happen? The number of row will become n and the number of column will become m. A very simple example you can see. A matrix is equal to 1, 2, 3, 4 and 5 and 6. Okay. Now the number of rows is 3 and the number of columns is 2. The moment we transpose the student, what will happen? The number of rows will change to what? 2 and the number of columns will change to 3. That's it. Okay. So what is happening in the transpose part is the rows is getting interchanged to columns and the columns are getting interchanged to rows. Very simple. How do we denote it? That is a bit dash, that is also, or a transpose. Both the methods we use it. Okay. Don't get confused in this. Okay. Now, coming to the property section, very important properties for the exam point of view, for your PUC part. Okay. So few properties are very simple. So the first, if you transpose one time and again transpose it, you get the same matrix. That doesn't happen in life. You do one mistake and do again, you'll end up in a bigger mistake. So don't do that again. Now, coming to the second part, if I have A matrix, then plus and then B and then transpose is there. Very simple, just open the transpose, A transpose plus B transpose, simple. If it is minus, it will be same thing, students. Okay. If we have A minus B whole transpose, that will be same thing as A transpose minus B transpose. Now coming to scalar multiplication and then transpose. Let's say we have Ka, you're multiplying a scalar K and to a matrix A and then doing a transpose. So that is equal to K and then transpose it first. So you can do the multiplication later. You can just transpose the matrix first and do the multiplication later, students. Now this is very important. A-B multiplication, whole transpose, very important for your KCET part also. Okay. So A-B whole transpose can be written as what? B transpose and A transpose. See here, the most important part, your B is coming first. A-B whole transpose in this, your B is coming first, students, and then A. Okay, so whatever is last, it comes first. So if we have three matrix A, B, C, then what will happen? If I'm doing a transpose, first the last one will come, then the second last, and then the first one. Okay, same thing if A power n is there and then transpose is there. So what do you do? First do the transpose and then do the power n. Okay, if you have A power n and then transpose, so what do you do? First do the transpose and then do the power of it. Okay, very simple and important for KCET. These three are very important. Now, same thing for the inverse, which we'll talk about a bit later. Just showing you the properties. AB whole inverse is nothing but equal to, first we'll get the B inverse, student, and then the A inverse. Okay, so very important. A lot of times students do mistakes in this. Don't do it. Now, if you have more than one matrix, okay, we have a combination of, let's say, A1, A2, dot, 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 till AN. We have n number of matrices and then transpose. So what we'll do? First, the last one, then the second last, like that, till A2 and then A1, the first one. Okay, just reversal order will do. Okay, whatever is in the last will come at the first. Any doubt, do put in the comment section along with the timestamp. Okay, or you can put it in the WhatsApp group. We'll try to make sure that your doubts are clarified in the doubt sessions. Okay, now we have a matrix A is equal to 1, 2, 3 and 4, 5 and 6. Now here we have B is equal to 2, 1, 3 and 5, 4, 6. Now what they're trying to say is you have to verify all the properties. Okay, all the properties means whatever the properties we have listed here, you have to verify them. Okay, so what do you do? Pause the video, solve this one example. Okay, and if you have any doubt, put it in the comment section. In our solved video, we'll put this solution of this part. Okay, and if you don't need it, you can just skip it. Now students who are thinking that the pace of the crash is a bit slow, you can fast forward and you can watch the lectures. And for whom you are thinking it is a bit fast, you can just slow it down or stop it, the point where you are not understanding, again go back, again understand, and then come back. And the same, I won't be repeating again in the next video lectures. Do take a pen and a paper, write it down. Writing is most important, students, because it feeds the data in your muscle memory. In exam time, you might forget what you have understood or what you have like remembered, but if you do it by writing, it will remain in your brain like a muscle memory and your hands will automatically write it down. Okay, next, coming to the next section, very important topic, students, symmetric and skew symmetric. For the KCET exam purpose, a lot of questions are asked each year from this topic. Okay, so let's see, what is a symmetric matrix? Now the definition is pretty simple, students. The moment we understood what is a transpose, if the transpose of any matrix is equal to the same matrix, then we say it is symmetric. Means A of ij, if you change it to row and column also, will be equal to A of ji, we can directly say it is symmetric. Okay, nothing more than that. It is symmetric matrix. Okay, clear? Now, if we get what is skew symmetric? The skew symmetric is a bit different. Not much difference is there, but the concept is almost similar. Skew symmetric is what? A transpose is equal to what? Minus A. Okay. Here we have A transpose equal to just A, and here we have A transpose equal to minus A. Here A of Ji is equal to what? Minus of A of Ij. Okay, students. So nothing much difference, but only bigger differences. Don't take it like fully same. A transpose equal to A here, then it is symmetric. A transpose equal to minus A, it is skew symmetric. Okay. Now, one very important question, students. Can all square matrix is either a symmetric or a skew symmetric? If they give you a very small question, okay, that every square matrix out there in the world is either symmetric or skew symmetric. So what are you going to say? No. The answer is no. Why? Because there will be like matrix like 1, 2, 3, 4. It's a what? Square matrix, because number of rows, number of columns is same. Okay, but it is neither what? Symmetric nor skew symmetric. So there are matrices which are square matrix but neither symmetric nor skew symmetric. Okay, now one very important point here for a skew symmetric part. In a skew symmetric, all the diagonal elements of a skew symmetric matrices are 0. Now you say, sir, why? Why is this? Okay, though maybe few people will know. So let's say, now in case of skew symmetric, we know what are the diagonal elements where I is equal to j. Now when A of ii is equal to minus of A of ii, so what are you going to do? Bring it both one side. So 2 of A of ii will be equal to 0. So A of ii will be equal to what? 0. So what you can see for the diagonal elements where I and j both are equal, they're equal to what? 0, students. So very important point. Do write it down, okay? And do make a note. And if you want, you can upload your notes. We can check and we can comment whether you're doing it good or not, or we can give you a few pointers on that. Now coming to an example, let's see. Let's see an example. We have a matrix A is equal to root 3, 2, 3, 2, minus 1.5, minus 1, 3, minus 1, 1. Now when we do the transpose, students, okay, you can see the rows we are changing it to columns. So this whole column we have taken and made it as one row. This whole second thing we have taken as a second column, we have made it as second row. And the third column we have made it as third row. Okay. So now understand it is what? A symmetric one. So we can see that A transpose is nothing but exactly equal to A, students. Okay. So when we interchange the rows and columns, we got the A only. So we can say directly it is symmetric. Okay, pretty simple. What is the concept? A transpose equal to A. Keep saying along with it. Okay, you will learn very faster. Now, coming to the second, directly by seeing only we can see that the diagonal elements are 0 and these elements are E, F and G and these are minus of that. If I transpose it, student, what will happen? These non-negatives will come here and the negative part will come here. If I take a minus common, it will be exactly same as the matrix. So that is equal to A transpose is equal to minus A. So it is skew symmetric. Okay, very simple, clear, done. So this is the concept behind symmetric and skew symmetric. Let's see the properties from there. The questions are always asked in your KCET. Now let's see the properties important for KCET for any square matrix. Okay, A plus A transpose, always keep in mind it will be symmetric. Okay, A plus A transpose will always be symmetric, and if you do A minus A transpose, it will always be skew symmetric. So these formulas should be on your fingertips because a lot of questions will be asked directly and you can use them directly and solve and save your time. Okay, it will just take like 10 seconds and you will be done with the question. Now for any square matrix A, okay, understand every square matrix A can be written as part of symmetric and a part of skew symmetric. So very important, a lot of questions each year is asked in your PU also, in your PU board, as you're writing the PU boards, okay, this question is pretty common, and for the people for the KCET also, this is very important. Now, if we have two matrices and both are symmetric, if A and B both are symmetric, then what will happen? If AB is equal to BA, then it means that AB is symmetric. Okay. So understand, very important questions are directly asked from, what do you say, this part, This part is there. This kind of questions are there in your exemplar also, students. Okay, this is a kind of short trick you need to keep that in your mind. Whenever they have given A and B are symmetric, and they have given you that AB is equal to BA, you can directly say that AB is symmetric, students. Okay, or they can change it vice versa. A and B they can give you symmetric, and they have told you that AB is also symmetric, so you can go to this. You can say that AB is equal to BA. Okay. Now, coming to the second part, the most important properties. If we have anything like B transpose A and B. Now we have three matrices. One is the in between. We have middle a different matrix, and then the starting and the ending we have B and B transpose. Now understand, in this case, the whole, whether this whole thing will be symmetric or not depends on which one, the middle A, the middle matrix A. If that middle matrix A is symmetric, then it will be symmetric. If it is skew symmetric, it will be skew symmetric. So very important trick for your KCET. Okay. Now, if A is a symmetric matrix, then A power n can be symmetric if n is a integral numbers, positive integers like 1, 2, 3. Okay, clear? If A is a symmetric matrix, A power n will be symmetric, students, for all positive integral, or integers. Okay, integral means what? Integers, students. If A is skew symmetric, A power n can be symmetric when n is even integer, positive even integer, and skew symmetric when n is odd even integer. So understand, if A is symmetric, A power n will always be what? Symmetric. If we have positive integers, A power n is skew symmetric, then it can be symmetric. Okay. Understand, student? If A is skew symmetric, then A power n will be symmetric if the value of n is positive even integer, like n equal to 2, 4, 6, 8. Now, if you say, sir, if A is skew symmetric, A power n, when it will be skew symmetric? If n is equal to what? 1, 3, 5. So what will happen if I know that A is skew symmetric? Okay, understand this part, very important. If A is skew symmetric and they have asked what is the value of A power 3. So directly we can say A power 3 will be what? Skew symmetric. You don't have to solve anything. I've made a shortcut here also. A power n whole transpose is nothing but A power n. Okay, and where n is even, then we get A power n minus of A power n where n is odd. So it will be symmetric if n is even. If it is odd, it will be skew symmetric. Okay. Now coming to the next, if a matrix is both symmetric and skew symmetric. This question has been asked a lot of times in your PU and KCET. If a matrix is both symmetric and skew symmetric, it always has to be a null matrix. Okay, clear? Now, if A is symmetric, student, okay, and B is also symmetric, and A and B are of same order, then this is a trick. AB minus BA, directly you can say skew symmetric. AB plus BA will be symmetric. A plus B will always be symmetric. So directly you can go through this. Okay, I'm not going on the derivation part since we are not teaching as of now for the PU part, students. So if you need derivations and other, we'll be bringing for the PU part a bit later. Okay, once the KCP is done. Now let's see the last part, inverse and the elementary row operations. What is basically an inverse of a matrix, student? If A is a square matrix, the first condition, A should be a square matrix. Order what? M. Now if there exists such other square matrix B of same order such that AB is equal to BA and that is equal to I in terms of matrix, or 1 in terms of matrix, or a unit matrix, then we say that A is a inverse of B or B is a inverse of A. Both is true. Okay, don't say that only just if AB is equal to I and BA is also equal to I. So we can directly say from here is that A is equal to B inverse and B is equal to what? A inverse, student. Okay, pretty simple as it is. You can check it also. Let's say we have taken a matrix A, we have taken a matrix B, and we have multiplied them. So what we got? We got I. So we can directly say that B is inverse of A and A is inverse of B. Okay. Now, very important property here. If inverse of any square matrix, if it exists. So first thing is there is a condition we need to check whether it exists or not. Now, once we know that it exists, the matrix is unique. Okay. The inverse, it cannot be like it has 2 or 3 or more inverse. Okay. It will have only one unique inverse. Okay. Inverse of a square matrix if it exists. Very important, students. It cannot exist also. If it is existing, then it is always unique. Okay. Coming to the next part, elementary row transformation. We have three things which we can do. Three rules we need to follow. Okay. Very simple, basic three rules. Now, all the solved examples and PYQ will be coming separately on the PDF sheets that will be given in the description link or will be given in the along with in the WhatsApp group. So do join the WhatsApp group for the doubt sessions and for the PDFs also. Now, elementary transformation, friends. First thing what we can do, we can interchange any two row or column. What we can do, we can interchange any two row or column. Means row 1 can be interchanged with row 2. Okay. Or column 1 can be interchanged with column 2. Pretty simple. Now, any row or column can be multiplied by a non-zero scalar. You take a row 1, and then multiply with 2 times of row 1. That's simple. Or you take a column C2 and then multiply C2 into 5. Whatever you want, you can multiply. Okay. Now, any row or column can be multiplied by K. Now, any row or column can be multiplied by a non-zero scalar. So, if we have row 1, that will be equal to row 1 into 2. And if we have column 2, we can multiply column 2 into 5. Now, coming to the third point, students, very simple. We're just combining, this part and adding it up and telling you any row or column can be multiplied by K and can be added to any other row. Means, what we are doing is we're taking row 1 and we're writing that row 1 is equal to row 1 plus 2 times of some other row which you have multiplied, like let's say row 3. Okay, so we can do that. And same thing is applicable for column also. Let's say we have written column 2 is equal to column 2 plus 5 times of column 1. So we can do, so what we have done, we are adding column 2 with what? Another column, and in that column we have multiplied something. So we can multiply something to a column and add it to a column. Okay, so here we are doing two things, students. First, we are multiplying something to a column and then we are adding to a column. Okay. Now, that sums up for the whole concept video and formula for the matrices part. We'll bringing it very soon, the determinants parts also. Okay. Do spread, like, share and subscribe. And for any doubt section, for any doubts, do join the WhatsApp section. Do join the WhatsApp group. Okay. And do comment if anything you have doubt in the video, including the timestamp. Okay.